Okay, let's talk about the quotient rule. The quotient rule is good for taking the derivative of something like this, where you've got a fraction, where you've got a function on top and bottom. And it's written out like this, where you've got the derivative of f over g is g times f prime minus f times g prime over g of x squared. The way I remember this, though, is instead of thinking in terms of g and f, I think of it as uh, taking the derivative of high over low. And I use this as my device for memorizing this. The derivative is going to be low d high minus high d low over low low. Now, what that means is low is the bottom, d high is derivative of the top, and d low is derivative of the bottom, or derivative of low. And that's what I think every time that I use the quotient rule. And a couple of things to keep in mind: order matters. Low d high minus high d low. If you reverse these, if you did high d low minus low d high, that's wrong. What that'll give you is the negative of the derivative. So when you do this, be sure to get the order right. I would say by far that's the most common mistake I see people making with the quotient rule, is getting that numerator backward. So let's do some examples. Let's see. First up, find the derivative of this. Oh, I've got a straight 3 here. Let me get rid of that. Find the derivative of this. Okay, f prime of x is going to be low d high, so derivative of 3x is 3, minus high d low, derivative of that denominator is 2, over low squared. All right, now we need to simplify, and let's first talk about what not to do. A lot of the time people see this and they see they see both of those 2x plus 5s and they say, hey, let's cancel this. But you can't do that, because in order to do that, you would have to have a 2x plus 5 in this term as well. So what we have to do is distribute the 3 across here and then combine like terms. So if we do that, we get 6x plus 15, and then minus 6x over 2x plus 5 squared. And so those 6x's cancel. You get 15 over 2x plus 5 squared. And that's my derivative. All right, let's do another one. Find the derivative of this using the quotient rule. Now, the reason I say using the quotient rule here is because this one, we've already seen derivatives of functions like this, where you just have a single thing on the bottom, a single term. So we could do this using the quotient rule, or we could do it by first splitting it into 3 fractions. And that's what I want to do here in example 3.1.2 and 3.1.3. We'll do this both ways, and we'll see that we get the same answer. All right, so using the quotient rule, we get f prime is, let's see, low d high minus high d low over low squared. All right. I might be a little short of space here, but we'll make it work. Distribute this out, you get 2x to the 4th plus 2x cubed minus, I'm going to distribute the negative 3 and, the 3x squared and the negative at the same time. So let's see, we get minus 3x to the 4th minus 6x cubed minus 3x squared. And all of that's divided by x cubed squared, which is x to the 6th. So if I combine my terms, let's see, x to the 4th, x to the 4th, that gives me minus x to the 4th. Let's see, my cubes give me minus 4x cubed. Then I get minus 3x squared over x to the 6. Now I could leave it like that, or I could rewrite it. I'm going to write this kind of small, so I'm magnifying it. What I could do is cancel off x squared, because everything in here has at least x to the second power. So if I cancel that off, I get minus x squared minus 4x to the first power minus 3 over x to the fourth. So that's one way I could write my answer. Okay, now let's do it without the quotient rule. So I'm going to do a couple of things here. First up, I'm going to rewrite it. F of x is x squared over x cubed plus 2x over x cubed plus 1 over x cubed. And I'm going to rewrite that as, well, let's see, each of these, x, this will be x to the negative 1. Next one will be 2x to the minus 2, then x to the minus 3. Now I can just use the power rule. So this first one will be minus x to the negative 2, then minus 4x to the negative 3, minus 3x to the negative 4. And I could leave it like this, or I could change it. I'm going to leave it like that because I don't want to do anything extra. But let's compare these. Are these the same? Yeah, they are. Because if you took this one up here, I'll do this in green. If you took this one and split it into 3 different fractions, you'd get, this would be minus 1 over x squared, and this would be minus 4 over x cubed, minus 3 over x to the fourth. And that's the same as what we've got over here, just written with denominators instead of negative exponents. So both ways get you the same answer. Which way is better? It doesn't matter, they're the same. Do whichever one you like. I want to skip this example for a second, the 314, because I want to point out the next. I don't have the next example that I wanted. Okay. One thing I want to mention, though, if you had something like g of x equals x squared plus x plus 1, if what you have in the denominator were something like x squared plus something, that you would have to use, you have to use the quotient rule on this. You can't split it up into 3 fractions and just do it. I guess you could technically split it into 3 fractions, but then you'd have to use the quotient rule on each one of those. And the difference is this up here just has a single term in the bottom. This has something more complicated. All right. So let's do this example. H of x is equal to g over f, and we're supposed to evaluate h prime of 2. Okay, so h prime of x is going to be low d high minus high d low over low squared. All right, so h prime of 2, that's going to be f of 2 times g prime of 2 minus g of 2 times f prime of 2 over f of 2 squared. And we'll just have to pull the numbers out of this chart. Let's see, f of 2 is 1. G prime of 2 is 7. G of 2 is 9. f prime of 2 is 4. And f of 2 is still 1. We got lucky there with a denominator of just 1. So let's see, what is this? So I'm going to finish it over here. This is 7 minus 36. So it looks like a negative 29 is our answer here. By the way, these are called sparse information problems because they don't tell us the whole function. They just tell us a bit of information about it. All right, let's see. What else do we have? All right, last example for this video. Find for which values of x is the tangent. Now, I've got this written a little badly. For which values of x is the tangent of the graph? For which values of x does the graph of this function have a horizontal tangent? Give exact answers and also round to 3 decimal places. Okay, so let's take the derivative. F prime of x is low d high minus high d low. Derivative of the bottom is just 1. I'll write it in there just for completeness, over low squared. All right, let's see, what's this work out to? 2x squared plus 6x minus x squared minus 1 over x plus 3 squared. Combine that together, you get x squared plus 6x minus 1 over x plus 3 squared. Okay, that's the derivative. But we're asking, where does it have a horizontal tangent? It has a horizontal tangent when the derivative is equal to 0. So what I need to do here is set this equal to 0 and solve. I'm using a different color there because I want, well, I don't like doing this because it looks like if you read all these equals across, f prime of x is equal to 0. So it's kind of bad form to write it like that, but I'm going to do it because I don't have a lot of space left. Okay, so to solve this thing, what I would do is first multiply both sides of this equation by x plus 3 squared. When I do that, that gives me, I better come over here to do it. That gives me x squared plus 6x minus 1 equals 0 times something. I'm not going to write the x plus 3 squared there because it's multiplied by 0. It'll go away. So we've got to solve this equation here. You could try to factor it, but it's not going to work out. We've got to use the quadratic formula. So x is equal to minus 6 plus or minus the square root of 6 squared minus 4 times 1 times negative 1 over 2a, so over 2. So let's see, that's going to be minus 6 plus or minus square root of 40 over 2. I'm getting down here into the other problem. That's okay. So this is minus 6 plus or minus square root of 40. I'm just going to do this scratch work. You can rewrite this as a square root of 4 times the square root of 10. So it's 2 root 10 over 2. So negative 3 plus or minus the square root of 10. Those are the exact values. Now, for the approximate values, I'm going to put in negative 3 plus square root of 10. My calculator says that is approximately, what did I say, 3 decimal places, 0.162. And if I put my negative 3 minus 10, minus square root of 10, that's negative 6.162. So let's go to Desmos and check that. All right. The graph we're looking at is x squared plus 1 over x plus 3. which looks like this. X squared plus 1 over x plus 3. Yeah, okay, let's I thought there was a problem because it looks like it's got a minimum at 0 here. But if we zoom way in, notice right here, yeah, there we go. The x coordinate there is 0.162, and that's one of the ones we got. The other place where it has a horizontal tangent is down here at that point, and this point has a x coordinate of negative 6.162, which is what we got. All right, so we'll stop this video here.